Hello children. Today we are going to learn about electric charges and fields. This will come under electrostatics. See, electrostatics deals with the study of force, fields and potential which arises due to the static charges. See, students will be able to understand the charges, types of charges and the properties, and they can easily describe the Coulomb's law, about Superposition Principle and the continuous charge distribution. Let us see in detail. Charge. See, the charge which is nothing but the basic unit of the matter. There are two kinds of charges, that is positive charge and the negative charge. And if suppose a body is charged, which means what? It has either excess of electron or deficit of electron. The body has excess of electron, which means it is a negatively charged body. If suppose the body is positive in nature, the body has deficit of electrons, electric charges and its property we'll see. See, here we can say about the frictional electricity. The frictional electricity, which is nothing but the property of, or we can say that it is produced by rubbing the body over another surface. We can know about clearly by seeing the diagram, we can understand. Right. See, first diagram we have glass rod with the silk cloth. The next diagram we have ebonite rod with the fur cloth. The first one, glass rod, which is rubbing over silk. What will happen? Obviously silk mean that glass rod contains loosely bound of electron. It will loses the electron, so that it will get the glass will loses the electrons or deficit of electron. So silk acquires the electrons. So that is negatively charged object. It will become a negatively charged object. Now we'll see the next example, that is the ebonite rod with the fur. The fur, it has loosely bound of electron. So that the fur loses the electron, the ebonite rod is excess of electron. It will become excess of electron, the negatively charged body. So by that way only the charges are transferring. So this we can say that frictional electricity. Next we will see gold leaf experiment. See, the gold leaf experiment, which is nothing but the device which is used to know the amount of charge and the nature of the charge in a body. You are seeing on the screen the diagram. See, on the top we have metal knob. The metal knob contains a metal field, the metal rod. So the metal rod ends with what? Gold leaf. If suppose you are taking a charged body near the object, what will happen? This knob is, it touches the knob transferring the electrons through the metal rod, and the gold leaf will get diverged. See, the diverging, the degree of divergent, with the help of the degree of divergent, we can get how much amount of charge got transferred. So this is the gold leaf electroscope. This is helpful to know about what? Yes, the nature of the charges and how much amount of charges which is transferring. Now, we'll see that what are all the methods of charging. As we before said, the frictional is one of the method. That is friction, conduction and the induction. Frictional, what we said? That is transferring the charges. One body transferring the charges to another body. The next one is induction. What is induction? We are inducing the charges. We are inducing the charges without actual touch of the body. How it will possible, ma'am? How you are saying that without touching the body, how can we transfer it? In the lower classes, we are not know about this concept, right? You may know about this better by seeing the diagram very clearly. See the diagram, we are having two spheres on the screen. The first diagram we are seeing on the screen, two spheres, that are all the metal spheres, It is a neutral one, neutral body, right? Now, we are bringing a charged object near the sphere. And the second object, you may notice that is the charged object near the metal sphere we are bringing, right? Now, what will happen to that neutral body? It will automatically align that the charges which is opposite to the charged body will attract, and the same kind like charges repel to another side. And after some time, what will happen? The neutralized body, suppose you remove the charged object, it will get neutralized, right? So this is the method we are telling that the charged by induction. That means what? Without actual touch of inducing the charges, that is called charging by induction. So charging by conduction, as we know that very well from our lower classes, we are studying about this. What is that? The process of charging by conduction, which is nothing but direct contact of charged body and the uncharged body. Which means what? If suppose the negatively charged body object is used to charge a neutral object, then both the objects become charged negatively. Got it? Basic properties of charges. See, we have three basic properties of charges: additive of charges, quantization of charges, and the conservation of charges. Let us see one by one in detail. Additive of charges. If a system of charges containing a point charges, suppose Q1, Q2, like the total charges of the system is obtained simply by adding the charges algebraically. That means what? If suppose the system contains Q1, Q2 till Qn, which means what? We are adding it Q1 plus Q2 plus Q3 till Qn. The next one is conservation of charge. Conservation of charge, which means what? We know that very well. The charge is conserved, which means the total charge is isolated system is always conserved, which is nothing but the isolated system contains of many charged bodies due to the interaction of among between the bodies, right? Quantization of charge, that is the third property. See, that we can say that the experimentally it's established by the free charges or integral multiple of the basic unit of charge. So we can say Q, which is equal to Ne. So these are the three basic properties of charges, right? Now let us see Coulomb's law. See, the Coulomb's law, which given force between the two charges, two point charges. That means the charges are pressed. You may see on the screen the diagram, the statement which says that the force of attraction or repulsion between the two charges is directly proportional to the product of magnitude of two charges and inversely proportional to the distance, square of the distance between them. See, Coulomb's law for the stationary charges of the point charge, we are seeing on the screen Q1, Q2 and R. The distance between that is R. What is the mathematical relation? We will see. So, the force of attraction and the repulsion between the product of magnitude of charges is directly proportional, right? So, that what it will come? F is directly proportional to Q1, Q2. And F is what we said? Inversely proportional to 1 by R square. So, we can say that F, which is equal to Q1, Q2 by R square into K. We have taken K is the proportionality constant, that is the Coulomb constant. So, we can say the value of K, which is equal to 1 by 4 pi epsilon naught. So, the value of K, which is equal to what? 1 by 4 pi epsilon naught. So, the whole value of 1 by 4 pi epsilon naught, which is equal to 9 into 10 power 9 Newton meter square Coulomb power minus 2. See, we can see now some facts or limitations of Coulomb's law. See, Coulomb's law should be for only the point charges of stationary charges. The charges should be at rest and it will obey the Newton's third law and it will be very valid and suitable for the superposition principle. Let us see the superposition principle in future slides. And the force between the like charges is repulsive and between the unlike charges attractive. Right. So what is the Coulomb's law in vector form? See the diagram. We must consider two charges should be positive or either negative. That means what? Like charges we have to take it. And it is separated at a distance of r square. Right. Now what is Coulomb's law? Yes. Pause the video and we have to recall it. Yes. Now you know that 1 by 4 pi epsilon naught q1 q2 by r square. So that is Coulomb's law. Now we are applying the charge which is for the charge on q1 due to q2, that is the vector form of force F12 and force 2-1, right? Charge 2 on due to 1. We are seeing in the vector formation. So what will happen? F12 vector which is equal to 1 by 4 pi epsilon naught q1 q2 r square r cap 1 2. Here we are taking F12. So r cap 2-1 you have to take, because why? The charge on 1 due to 2, second charge, right? The same way we have to take it for the force which is for 2-1. Here what is the value will come? The same way we have to apply 1 by 4 pi epsilon naught q1 q2 by r square r cap of 1 2, because this is for the force 2-1, right? So by applying these things you may understand this is obeying Newton's third law, which is what? F12 which is equal to minus of F21, right? So Coulombian force obeying Newton's third law, right? Superposition principle. See, the electrostatic force experienced by a charge due to other charges in the vector sum of electrostatic forces due to these other charges as if they are existing individually. That means when n number of charges which is interacting in a system, the force of the charge, a single charge, is depending, or we can say the individual algebraic of other charges. So F1 vector which is equal to, we can say F11 or F12, F13 plus F14 vector till F1n, because n number of charges which is interacting on it, right? So the next one is, we will see the continuous charge distribution. What is continuous charge distribution? See, a system of closely spaced charges are said to be continuous charge distribution. Actually, the charge, the electron which is discrete in nature, we have to assume here continuous charge distribution. So it has three different way we can say the continuous charge distribution. For that, line integral or line, one single dimension, one dimension or two dimension and three dimension. Let us see one by one in detail. So line or linear charge density we can denote it by lambda. If the charge is distributed over a straight line or a one dimension, we can say the distribution is a one dimension or a linear charge distribution. See the diagram on the screen. See, we have the straight line, that is dq, we can take it. We have to take it for the small instant of value. So lambda which is equal to what we said, the linear charge density is the charge per unit length. The SI unit we can say Coulomb per meter, right? So the lambda which is equal to what? Q by L. As per the statement, the lambda which means what? Linear charge density, that is charge per unit length. So lambda which is equal to Q by L. So lambda here we have take dq by dl. We can take integrate it, then only we can get for the whole system. So that we are integrating the integral over L, lambda q which is equal to integral over L, lambda dl. The same way we can see for the surface and volume. Surface charge density, that is denoted by sigma. Here surface means we know that very well, that is plane. So the rectangular components of 2, x and y axis we have to take it. So if the charge is distributed over a surface area, then we can say the distribution is what? It's a surface charge distribution. So surface charge distribution, which is nothing but the charge per unit surface, right? So sigma, which is equal to Q by S. See the diagram, we have to take small part from the area, then we can integrate for the whole system. So sigma, which is equal to ds by dq by ds, right? So dq by ds, the total charge surface S, which is equal to Q integral over S sigma ds. The same way for the volume. You can easily understand that, right? Volume means what? 3 dimension we have to take it. So if the charge is distributed over a volume, then we can say the distribution is what? Yes, volume distribution. That is volume charge density. Rho, we can denote it here rho. So rho, which is equal to Q by V. Here, see the diagram, we have taken only for the small part. We have to take it for small part. So differentiating it. So that only we are saying rho, which is equal to dq by dv. So we got the total charge for that volume V, Q, which is equal to integral over V, rho into dv. Got it? Right. It's time for assessment. Now see the questions which are present on the screen. Read all the questions. Just try to answer for all the questions. If you want to know in a better clarity of ideas, just recall what we have studied through the video, right? Let us discuss the answer for the questions. So question number 1 is what? Yes, ebonite rod is rubbed with wool or fur. What type of charges do they acquire? See, the ebonite rod acquires negative charge and fur or wool acquires positive charge, because fur is loosely bound of electron. So it loses the electron, so it will get deficit of electron. The ebonite rod acquires negative charge, excess of charges, right? The second question is, name any 2 basic properties of electric charges. You know that very well. 1, any 2 basic charges, additive in nature, quantization, or you can take conservation, right? In detail you have to write it, right? Now the next question is, define the SI unit of charge. The SI unit of charge, electric charge, which is Coulomb. So 1 Coulomb is what? 1 Coulomb is that the amount of charges which an equivalent similar charges with the force of 9 into 10 power 9 Newton meter square per Coulomb square, right? The fourth question is, write down the value of absolute permittivity of free space. Absolute permittivity of free space, which is nothing but epsilon naught value. Epsilon naught, which is equal to 8.8542 into 10 power minus 12 Coulomb square Newton power minus 1 meter power minus 2, right? Fifth question is, define Coulomb's law, and also you have to write the mathematical expression for it. What is Coulomb's law? Yes, the statement is, the force of attraction and the repulsion between the 2 charges, the stationary charges, that means the point charges, is directly proportional to the product of magnitude of the 2 charges and inversely proportional to the square of the distance between them. The mathematical relation F, which is equal to K Q1 Q2 by R square. Let us recall what are all we studied in this video, right? Now, types of charges we see, the properties of charges and types of charges, 2 different types of charges, that is positive, negative. So, what is positively charged? Excess of that electron is negatively charged, deficit of electron positively charged, and properties we see in that it is exist, like charges repel, unlike charges attract, and the basic properties, what are all the basic properties? That is additive in nature, quantization and conserved. And the next what we see in that Coulomb's law. Coulomb's law, F which is equal to, that is force of attraction, repulsion between the two charges, the magnitude of product of two charges is directly proportional and inversely proportional to the square of the distance between them. What is the mathematical relation? So for recalling it, you have to know, to pause the video and recall it. Again, you can go and see that. Yes, exactly. Now, F which is equal to Q1 Q2 by R square. F which is equal to K Q1 Q2 by R square. Right. What is superposition principle? When a number of charges are interacting in a system, the total force given charge, which charge we need to know about, the charge is the vector sum of the other charges due to the all other charges present in a system. Right, continuous charge distribution. So these are all the things we have studied.